AI-based hotspot prediction in multi-core processor is our project title. Now, actually, our processors which we have in our computers will be having cores, multi-cores. For example, dual core, octa-core, hexa-core, quad-core, and whatever it is. And these all processors will be having a cooler fan, and this cooler fan will be treating the processor equally. But equally treating the processor is very inefficient way, because the core which is producing more heat and the core which is producing less heat will be treated equally, but that is not an efficient way. So we are proposing a new approach called targeted cooling of the processor's core. So targeted cooling of the processor's core will be an efficient way. So we will be treating each and every processor by giving unequal importance to each and every processor. Now, for that, we will be calling the processor core which has more heat as a hotspot. Now, for this, we will be collecting the data from the system monitor. Now, our system monitor will be producing real-time performance metrics of the processor, which will be having the core temperature and the core's performance. So for example, if 76% or 66% or 50% of the performance metrics has been displayed for the core's performance, then corresponding temperature will also be displayed. And for that, we are writing a program in Python. And you can see that particular data collection Python program in this display. So using this particular code and with the help of a open hardware monitor software, we are going to collect the real-time data from the CPU performance and CPU temperature. Now we'll be uploading it into or recording it into a data frame, and that will be copied onto a Microsoft Excel, and from that we are going to train a machine learning model using LSTM, long short-term memory, which is a type of recurrent neural network, long short-term memory. Now you can see that the training code has been displayed here. Using this training code, we will be giving epochs of 100 for each iteration. Now this will be used for training, and now a weighted model, LSTM weighted model or the trained model, will be saved using the dataset. So the model gets trained, and now the model is trained. Now using this trained model, we are going to predict the hotspot. By predicting the hotspot, it will be displaying that core 4 is the hotspot. Our core more has particular temperature and this particular temperature, and we will be setting a threshold value, and from this threshold value, if the temperature of the core exceeds that particular threshold value, automatically it will be considered as the hotspot, and that will be displayed. This is what our concept is. So for this, we have also taken a literature survey of what are the concepts and approaches which have been given by all the scientists and researchers. And our base paper is from VLSI, the integration journal from elsewhere. Now we are developing this software for the hardware, which is microprocessor. So we hope this particular concept will be effectively reducing the heat of the microprocessor, and more specifically the core's temperature, which is producing more temperature or more heat, and that is called as hotspot. So we have implemented this project in 3 of the common real-world processors, which is dual core, quad core, octa-core, and we have got an accurate results after the prediction. So I hope this particular project will be efficiently reducing the cores or the processor's heat in an efficient way. Thank you.